We demonstrate our technique of miniaturized percutaneous nephrolithotomy in a case with multiple renal stones. The patient was scheduled for mini-PNL with Moses holmium laser lithotripsy. Preoperative computer tomographic imaging shows multiple stones in the renal pelvis and in the lower and middle calyces. We routinely place a ureteral occlusion catheter to dilate the renal collecting system and to facilitate the renal puncture. The patient is placed in lithotomy position. The ureteral catheter is entered into the orifice and a retrograde study of the upper urinary tract is performed to exclude ureteral stones or pathologies that have not been seen on non-enhanced CT. The balloon is now blocked with 2 cc air and pulled back into the UPJ. The ureteral catheter is connected to a Foley catheter and the patient is now turned into a flat prone position. The desired puncture area is limited by the ribs and the pelvic rim. We are using the MIP set from Karl Storz that consists of several sizes of sheath dilators and nephroscopes. The M system was selected for this case. A last generation luminous high power holmium laser with Moses mode was used for lithotripsy. The selection of a wide range of settings is possible and the Moses mode is an important development that improves energy transmission and reduces stone retropulsion. The renal collecting system is opacified by the injection of contrast agent through the catheter. A potential multi-tract access with 2 punctures was planned. It is important to stress out that the puncture is conducted under simultaneous ultrasound and fluoroscopy control, which gives, in our opinion, best visualization of the correct access and surrounding structures. We mix the contrast agent with methylene blue to prove correct access. The ultrasound probe is removed and the guide wire is introduced under fluoroscopic control. A second puncture is performed at the lower pole in the same technique. The lower pole access is now used for the primary access and the fascia is dilated by an 8 French Teflon bougie over the guide wire. The next step is the introduction of an 11 French stainless steel cannula to place a second wire that stays as a safety wire. The dilation is then continued by a 60.5 French dilator. Finally, a 17.5 French modified stainless steel amplatz sheath is positioned. When entering with a nephroscope, the pelvic stone can immediately be visualized, but it is too big for direct extraction. A 36 micron laser fiber is deployed and the laser lithotripsy is started with 1.6 Joule and 25 Hz, resulting in 40 watts. As already mentioned, the Moses mode adds significant efficacy, especially in the presented case with multiple mobile stones that tend to jump backwards with conventional laser application. After sufficient disintegration, the fragments can be flushed out passively. all stones that are accessible with a rigid scope are disintegrated and flushed out. Again, it can nicely be seen how effective laser lithotripsy works without annoying retropulsion. Finally, a solitary stone in the punctured middle calyx could not be reached. Instead of dilating the second axis, we decided to perform a flexible nephroscopy first. The calyx was difficult to reach, but eventually with supporting fluoroscopy we could visualize the stone. Note the safety wire of the second puncture that enters nicely transpapillary. The stone was captured by a 90 Knoll grasping basket and could be extracted without further disintegration through the amplatz sheath. Final endoscopic and fluoroscopic evaluation revealed no residual stones. We therefore decided to perform a tubeless procedure. The ureteral catheter was deflated and removed, followed by antegrade placement of a double J. Postoperative CT confirmed a stone-free status. The postoperative course was uneventful. In summary, we demonstrate the excellent efficacy and safety of our mini-PNL technique and the use of a high-power holmium laser with Moses mode.